I think you're muted, Professor.
Yes, I'm muted. Sorry. The next speaker is Ayushi Verma, and Mikhail will take the time.
Okay.
Okay, can you see my screen?
Yeah.
Okay, starting the timer now. Okay, so this is my poster, and the main takeaway of my research is that for PhD holders, the choice of their employment sector, whether that's in academia or whether that's industry, it strongly depends on teaching activity, on the size of their employer, and also whether or not they're receiving government support. So backing that up a little bit, my research question specifically is, can we predict the employment sector, again, whether that's academia or industry, of PhD degree holders, and then identify the key characteristics or the key factors that influence that career choice. So the reason that in the literature, I found similar or adjacent topics of research where they used a lot of statistical models and social science frameworks to explain different things. For example, the career paths of postdoctorates, or the turnover rates. So why are people leaving academia, switching over to industry, so on and so forth. But what I noticed there was a huge gap of was the lack of using data science methodologies, specifically machine learning, to be able to do this kind of analysis to help streamline that line of questioning. And so that is the primary objective of my research here. The data set that I'm using is a longitudinal survey data set spanning 2003 to 2013. It was a very highly dimensional data set, almost 500,000 rows and 126 columns. And so the first, the sort of analysis that I did was trying to reduce the size of that data set. And how I did this was investigating each of the 126 variables with my target variable, which is the employment sector. Some other things that I did in preparing my data was filtering it to only include people with PhDs, to only include people working in industry or academia, only including people who are fully, full-time employed, things like that. And then, doing that EDA and looking at the correlations and relationships between each of those variables. So I was finally able to get my data set down to like 119,000 rows and 23 columns. And so I used six, initially there were 7, but I ended up using 6 binary classification algorithms. So specifically that is KNN, gradient boosting, decision tree, XGBoost, logistic regression, and random forest. And using different evaluation metrics like accuracy, precision, recall, F1 score, looking at the confusion matrices, and also looking at the ROC, AUC scores, I found out that the top performing algorithm to predict, whether or not to predict whether a PhD holder is going to work in academia or in industry, the top model was gradient boosting, followed by decision tree, followed by XGBoost. Here at the top here is an example, is the decision tree output, and this figure over here is the feature importances, showing that the factors affecting that career choice are teaching, employer size, and again federal support from the government. So to conclude, this is a demonstration of the usage of data science methodologies, including machine learning, to a social science problem. And I hope that, more other researchers, trying to answer similar questions can use data science methodologies in the way demonstrated here to support their research, in addition to these statistical methodologies that they're already using. So some future work includes hyperparameter tuning. So because of my computer's hardware limitations, I unfortunately was not able to do any hyperparameter tuning. It was just taking way too long. So doing that to fine tune my model, to optimize on that that output. Also, I would like to use these machine learning methodologies in conjunction with the statistical frameworks that researchers in literature are already using, because I think that together these can tell a very quantitative and cohesive story to answer the questions. So here are my references, and then I've got a QR code to my GitHub repository that contains information, code and stuff. Yeah, thank you very much.
Thank you. I think there's 30 more seconds. I just wanted to, yeah, like if you have like to summarize what you did in like 1 or 2 sentences in saying someone doing a PhD will go in academia if what? Based on the parameters that you identify.
Yes. Yes. So one of the limitations of my research is looking very specifically into those exact parameter boundaries. Again, because of hardware limitations, I wasn't able to do that specifically. But from my exploratory data analysis combined with the domain knowledge that I learned from the literature review, so the top 3 factors that I found were teaching. So if one of the respondents is actively teaching on their job, chances are that they are working in academia as compared to industry, right? The second factor was employer size. So this one I don't have a specific answer to, but in the survey, there were different values for employer size. So whether that's a small company, 1 to 50 people, or whether that's a mid-sized company, 100 to 500 people, or whether it's a very big company, more than like 10,000 employees, that has some effect on the classification. But again, I wasn't able to examine that specific like boundary. And then the other thing was federal support. So if a respondent is receiving federal support from the government, chances are that they are working in academia, for the research as compared to industry. There were some other factors like salary. So again, higher salaries, chances are that that person's working in industry. Lower salaries, chances are that it's academia. And then one other thing was, I'm sorry, looking into my text. Development activities. So if the respondent is working on development activities, so I think that's things like doing software development, or maybe material development. That was, again, one of the other variables which I was not able to figure out the exact decision boundary. But this is definitely a, research to do next.
Yeah. Yes, thank you. Yes, and I'm happy to see how, in fact, you started, the question you started was much broader, vaguer, more vague, and then now that it became like much more concrete. Yes, thanks very much.
Thank you.
Okay, so our next present